So since it's International Women's Day today, I thought I'd take a moment to talk about a women mathematician who's been very influential in physics spaces, Emmy Noether. So she started her maths career around the turn of the 20th century, and her big contribution to physics is her Thirst theorem, the idea that for every symmetry there's a conserved quantity and vice versa. What we mean by conserved quantity is essentially just something that doesn't change, like say energy is conserved, momentum is conserved, things like that. You know this from your high school physics. And a symmetry is anything where we can alter a quantity by some amount and it won't change the overall physics of the system. An example of this is time translation symmetry. If you, say, run an experiment and then you run the experiment again at a later time, you should get the same results due to time translation symmetry. Adding however long you waited to do the second experiment to all your time measurements won't actually change the overall result. And what Noether proved is that this leads to conservation of energy. There's similar things with regard to conservation of momentum, and most importantly in particle physics. See, in particle physics we're constantly looking for symmetries. We need symmetries to do with the electromagnetic force, the strong nuclear force, the weak nuclear force, and we model them using symmetry groups, U1, SU2, SU3. This is all quantum field theory stuff. And what they're mainly looking for are things that are symmetry breaking. Does this interaction result in a change when you make one of these symmetry transformations? The most intuitive one of these is seeing the difference in antimatter and matter in the universe. We observe lots more matter than we do antimatter, and we don't really know why. But the amount of matter and antimatter in the universe is a conserved quantity in every particle decay. Each process that produces some amount of matter produces an equal amount of antimatter. Yet that's not what we see. So one of the things physicists are looking for nowadays is an interaction which to some extent breaks the symmetry, producing a little more matter than antimatter. This will allow us to have a matter-dominant universe like we see today. So that's how Emmy Noether is one of the most important figures in both women's STEM and modern particle physics.